Let's do some more examples of absolute value inequalities, and in a minute I'm going to give you a little bit of a shortcut to the recipe that'll save you a little bit of time when you do the problems. The first one is very, very simple. We've already done several, I believe, very similar to this. One thing we didn't talk about was absolute value equations. Let's make this an equal sign just up here as a separate problem. Now, what is the solution to this? What values of x make this a true statement? Well, it's simply 3 and negative 3. So in this case, it would be negative 3 and 3. I'm going to circle this. This is not the same as this problem. This is just an example all by itself. And notice I didn't shade anything. Only exactly those two numbers. Either one of them will make this a true statement, and that's it. Well, the solution to this, when you change the equal to a less than, 3 and negative 3 no longer work because 3 is not less than 3. You know, the absolute value of negative 3 is 3, and 3 is not less than negative 3. But this is going to be everything in between those 2 points. So we've already said that once you have x, absolute value of something less than a positive number, all you need to do is this. Every time. And that tells you what the solution is. The interval from negative 3 to 3. And to graph it, it'll look similar to this. Only I'll have a negative 3 and a 3 with a circle on them and shade everything in between. That's it. Well, there's only one other possibility with this one. Suppose it were, well, other than putting an equal sign in, less than or equal or greater than or equal. If that were greater than, what do you think the solution would be? It'd be everything outside, away from these 2 points. So absolute value of x equals 3 is just these 2 points. Absolute value of x less than 3 is everything in between them. Absolute value of x greater than 3 is everything to the right of 3 and to the left of negative 3. Okay, well, with that in mind, what's the solution to this? When you have absolute value less than a positive number, the answer will always look like that. The numbers might be different, but it's going to be an interval, one interval from this number to that number. This is a greater than. I already know that the answer is going to look like this, the solution. Oops. Negative infinity up to some number, union, some number to infinity. Because it's greater than or equal. It's going to have 2 intervals. And this left one will be the negative infinity in this interval and positive infinity in that. And it turns out it's just 2.5 and negative 2.5. Because this is all the numbers that are either, remember from the definition, either, this means either x greater than or equal to 2.5 or x less than or equal to negative 2.5. So this is a solution, and if you graph it, all you have to do is put a negative 2.5 there, put a 2.5 there, and shade outward from them. And since it's greater than or equal, and you have a square bracket on the 2.5s and the negative 2.5, shade it like this. Negative infinity is out there, infinity is out there. This is how you write the solution in the 2 different ways requested. The interval form, which is an interval union another interval. And this is how you shade it. So this interval corresponds to that one, this interval corresponds to that one. And one more time to review this one. If instead of greater than or equal to 2.5, it was equal 2.5, then it would just be the numbers 2.5, negative 2.5, and 2.5 shaded, and that's all. If it were absolute value of x less than 2.5, it would be shading everything in between these 2 points. So what you want to memorize is that absolute value less than a number, less than a positive number, is one single interval. absolute value of something greater than a positive number like that is two intervals. You're going to get two numbers on the number line and you shade outwards. Okay, let's get a couple of the special cases out of the way. Our recipe always said, I think in the recipe it said, what happens when you have absolute value of x less than the letter c, the variable c, which was a positive number. We didn't say what happens if the number on the other side of the absolute value is negative. What do you think the solution to this is? The absolute value of x less than negative 3. Don't try using the recipe. You can't, because this is not a positive number. Notice on the left, the absolute value of a number is always what? Or how about if I say it's never negative? It's going to be 0 or positive, right? Well, 0 and positive numbers are always bigger than a negative number. Is it possible to put a number in there for x, then take the absolute value, and have it be less than negative 3? Absolutely not. This is an empty set. There's no number that makes that true. Even if you plug in x a negative 1 billion, when you put the absolute value on it, it turns it into positive 1 billion. So this will never be true. All right, the other special case. We have the absolute value greater than or equal to a negative. The recipe didn't tell us what to do in that case. Well, maybe you can figure that out pretty easily. What do we know about the left-hand side? It has absolute value around it. No matter what you plug this in, it's not going to be a negative number. It's either going to be 0 or positive. Absolute value of 0 is 0. Every other number you plug into this, when you take the absolute value, it's going to be a positive number. Every positive number, and even 0, is greater than or equal to negative 2.5. Every real number works there. 10 is greater than or equal to negative 2.5, which means you can plug in negative 10 and get the absolute value. That'd be positive 10 is greater than or equal to negative 2.5. Every positive number is greater than or equal to negative 2.5. So those are two special cases. The recipe didn't mention them because they're kind of trivial. It's when the absolute value is less than a negative, absolute value greater than or equal to a negative. Okay, well, here are the first couple of problems that we've seen where it wasn't just the absolute value of x, but we have an expression inside the absolute values. But we still know what this means. It's the absolute value of something less than or equal in this case. I know what it's going to look like. One single interval. The solution will be this. All I have to do is find out which two numbers to plug in here. Okay, so we could simply do this. This means x minus 5. Remember how you can write this without the absolute values? You write it just like it is, but then when you remove the absolute value, you have to put this on the other side. Solve that. And whatever two numbers you get on this side, on the left and right, are going to go right here. Add 5 to all three sections. And what do we get? That gives us x in the middle, 7 on the right, and 5 minus 2 is 3 on the left. 3 and 7. I'll let you graph it, but it's quite simple. Just put a filled in circle on the 3 and the 7 and shade everything in between them. Here, let's get it in the correct form. Let's divide everything by 2 because we need the absolute value all by itself. So, absolute value x minus 3 greater than 1/2. Now we've got it in the correct form. So what I have is absolute value greater than something. So I absolutely know that the answer is going to be an interval unioned with another interval. Okay, so what does this mean? It means either x minus 3 is greater than 1/2 or x minus 3 is less than negative 1/2. And here's the way I like to solve these. I don't need to worry about the less thans and greater thans anymore. Just solve, let me do it this way. Solve this. And that will give you the two numbers that you need. Okay? So, this comes down to x minus 3 equals 1/2. I wrote it exactly the same way as it was without the absolute values. And on this one, I have to put a negative 1/2. Solve them and we're done. I call these, the two numbers we're coming up with, I sometimes refer to them as the magic numbers. 3 and 7 were the magic numbers in this problem. So, all I have to do here is add 3 to both sides. X equals 3 minus 1/2. X equals 3.5. So this would be, this one would be 2 and 1/2, and this one is 3 and 1/2. So the numbers are, you go negative infinity up to 2 and 1/2, and you go 3 and 1/2 up to positive infinity. Let me explain the magic numbers one more time. Going back to this problem, remember what I said? I know the solution is going to be, since it's less than or equal, it's going to be an interval that looks like this. All I need to do is find out these two magic numbers, which means I go x minus 5 equals 2 and x minus 5 equals negative 2. If you solve those two, so you're just replacing that with an equal sign, this whole thing. So you get a 7 here, and the negative one, you're adding 5, and you get a 3 there. Here, after we got to this point here where we have absolute value all by itself on the left-hand side, it's a greater than, so I know it's going to be, look like this. It's going to be two intervals. So all I needed to do at that point is say x minus 3 equals 1/2, x minus 3 equals negative 1/2. Make it equals, and these two numbers gave me these two results. And remember, when you graph it, that's probably what I should have done. When I graph it, sorry about that. When I graph it, all I need to do is get these two magic numbers and graph them, plot them. 1/2 and negative 1/2. Since I know it's going to be two intervals, I know I have to go from these two numbers outward. And it's a greater than, it's not greater than or equal, so I put open circles and I go outward. Just like that. This is the solution graphed. Over here, I knew the solution was going to look like, because it's a less than or equal, I knew it was going to look like this. One single interval. And all I needed to do to get the 3 and the 7 is set x minus 5 equal to 2, and x minus 5 equal to negative 2. And that'll give me these two numbers. That's a 3 and that's a 7.